Our everyday life is run by computers, from all the apps you run on your phone to the spaceships we send into space. Humans lead a very computer-dependent life. But what's better than a regular computer? Quantum computers, superior, faster, and improving our daily lives at an unprecedented speed. NASA had developed a quantum computer with the goal of changing the world as we know it using its unfathomable capabilities. But after something unexpected and startling occurred, NASA turned off its quantum computer. What happened? Why did the space agency stop something that would help advance our evolution? Welcome to Lab 360. It's time to explore. While everyone's attention is focused on AI, a significant development is taking place in the background. However, quantum computers are bigger than that. Quantum computers are a hardware question. They actually increase your ability to do much more than with an ordinary digital computer. The two of them, the chatbots that are a revolution in software and quantum computers which are a revolution in hardware, when they get together, watch out. But there lies a problem. Quantum computing can easily break encryptions. The first algorithm developed for quantum computing is Shor's algorithm, developed by Peter Shor. The algorithm can basically find prime factors for really large numbers. Apparently, that's the basis for RSA encryption. In 1977, three scientists, Ron Rivest, Adi Shamir and Leonard Adleman, came up with an encryption breakthrough named RSA, based on their initials. This encryption is so hard to break that even the best-known factoring algorithm, the general number field sieve, would take 16 million years to crack it. That's next to impossible, but not on a quantum computer. A quantum computer could crack it in a couple of days or hours. So that's the problem. RSA is the foundation of nearly all the public key cryptography we use today. Therefore, everyone is racing toward it, and anybody who solves this will have a big advantage, becoming the perfect hacking machine. But it's not so simple. Quantum computers are not your daily laptops and computers. They are much more. They are not meant to solve traditional problems solved by traditional computers. Instead, they solve problems that traditional computers cannot. Everything comes down to bits. Bits are made from pieces of silicon, with tens of thousands and millions of them in your computer. They can be in the state of 0 or 1, namely the ground state and excited state. Everything you type on your computer is translated into computer speech, which is binary, and we can have a billion of them on your fingernail, making the computer revolution a reality today. But a quantum computer can exist in both states, 0 as well as 1. This is called superposition. Unlike traditional computers, quantum computers function on qubits. Qubits aren't just 1 or 0, they are more complex. Imagine it as a wave. A qubit can likely be a 0, which means lower energy, or it can be a 1, which means higher energy. But in quantum computing, all waves are working together, which can be constructive or destructive. To put things in simple words, quantum computing calculates things differently, which makes it good at different tasks, especially at finding structure in tons of data. One part of quantum computing is simulating nature because nature abides by quantum physics. But Mother Nature would laugh at us because she does not use zeros and ones. Mother Nature computes on electrons, electron waves that create molecules. Our eyes cannot see it, but at the molecular level, the atomic structure of molecules follows the laws of quantum physics. For instance, anything that involves vast amounts of data, like developing new battery technology or creating new materials on a molecular level, will need a quantum computer. Things changed in 2013 when NASA and Google decided to make a commercial quantum computer. In other words, they would sell it to everyone who could afford it. However, just as the project was gaining momentum, the government unexpectedly intervened and demanded it be shut down. As a result, NASA was forced to close the project with no intention of ever reviving it. However, the question remains, what would happen if quantum computing and artificial intelligence were combined? In a recent interview, Michio Kaku disclosed that the world is unprepared for the potential consequences of integrating artificial intelligence with quantum computing. While AI systems have the ability to create and generate things, they are severely limited in their ability to distinguish between authentic and counterfeit content. In contrast, data created by artificial intelligence systems might be authenticated by quantum computers. But Kaku also brought up another serious concern about quantum computing, the fear that should the government obtain complete control over superquantum technology, it could use it to stifle dissent and opposing views. Imagine a situation where a terrorist plants a time bomb and uses a quantum computer to secure it. Because of this, many governments worldwide fear this possibility and even classify it as a national security issue. This type of scenario is known as post-quantum cryptography, and it is most likely the reason NASA was forced to halt its quantum project. Many experts fear that NASA will replicate what it did with the James Webb Space Telescope and quantum computing. Astronomers can now view the universe through a new lens, look farther into space than ever before, and capture the clearest pictures of innumerable cosmic wonders, all because of one scientific device, the James Webb Space Telescope. Photos from Webb have astounded both scientists and the general public, demonstrating what an incredible technological marvel it is. However, tech titans like Elon Musk are scared of this technology. They worry about the security of humanity and advocate for strict control over these advancements. What we're really aiming for here is to establish a framework for insight so that there's at least a third-party referee, an independent observer who can monitor what leading AI companies are doing and at least sound the alarm if there are concerns. Imagine all the cyber attacks and digital crimes that could result from the world's greatest quantum computer falling into the wrong hands. These problems are already becoming worse as AI evolves, and they might escalate further when quantum computing is added to the mix. The world's first artificial intelligence terminator could be created by quantum computing. It is true, quantum computing is a revolution in computer hardware, while artificial intelligence is a revolution in software. But combining the two without any control could result in something terrifying. Technological innovations will come at some point in time. Thank you for watching. What are your thoughts about AI and quantum computing? Let us know in the comments. Make sure to like the video and subscribe to the channel, because together we will explore.